Yeah, thank you very much. My name is Coskun. I am a professor at the University of Manchester, Department of Materials, and also I am the co-founder of Smartir. This is a spin-out company from University of Manchester. We are trying to commercialize the technology based on graphene-based adaptive surfaces. So we are using graphene-based devices to control visibility of an object, and we can change reflection of light from surfaces. And these devices can change their reflectivity from visible all the way up to microwave. So these are a couple of examples that we have been working on. And today I will talk about general physics behind this, and I will give you recent development in that field. So there are very many different materials that we can use. We can change color. We can use them as an adaptive optical surfaces. And I would like to give a couple of examples of that. A famous example is e-ink, and electronic e-papers are based on this e-ink technology. So there are colloid particles. By applying electric field, you can move this black and white particle in opposite direction, and you can change the color of a surface. And these are commonly used for, these are slow devices, but they are commonly used for electronic paper applications, e-readers. There are electrochromic materials, broad range of materials that can change their color by doing electrochemical reactions. And you can change absorption of a state, absorption of a material by doing electrochemical reactions. And Boeing is now implementing these materials for airplanes, so you can change the transmission of the window. And maybe you are familiar with this Duracell technology. They can understand the energy left inside the battery by pushing two buttons, which will pass current underneath, and it will increase the surface temperature of the strip, which is a thermochromic material. By increasing the temperature, then you can change the color. So if there is current, there is energy left in the battery. So it's an energy indicator. So these are examples for visible. If you go longer wavelength, infrared, there are some military applications. Camouflage is one of them. And can you hide visibility of a military vehicle? Can you do it dynamically by changing the infrared radiation from the surface? An easy solution is, if you control the temperature, surface temperature of an object, so you can change the appearance of this object in infrared imaging systems. And BAE is developing this technology by cooling and heating up the surface temperature. So if we go even longer wavelength, microwave, terahertz, there are new applications. Starlink is now using this new generation satellite antenna. These are smart antenna. These are phased array, and they can trace a fast-moving satellite on low Earth orbit, and they can change the direction of beam. Actually, this satellite contains many small antenna components. By controlling the phase, you can steer the microwave radiation. If we go even longer wavelength, microwave, and there are also other type of application for radar camouflage, for example. And so as you see here, these are all surfaces that wants to change their visibility. I want to give you an example. E-ink technology now recently has been implemented for different applications. For example, an electronic dress. You can see here, you can change the color of this dress by applying voltages and moving the pigments. You can immediately see this is not really comfortable. It's really like a display device and converted into a dress. And recently, BMW is implementing this technology to change the color of a vehicle. As you can see here, this car can change its color, and you can control it with your cell phone. It's quite a cool technology, and they cover the surface of this vehicle with this e-ink technology, and they can change color dynamically. And these are the examples that has been around for a while, and we would like to use graphene-based devices to control reflectivity of a surface. And our approach is a bit different. Instead of changing bulk material properties, we would like to control reflectivity of light by changing the electron concentration on an atomically thin layers. And graphene is a very unique platform to do this. But there are many challenges. The electron should be high mobility. We should be able to get high density of electron on that surface. And there should be no bulk material that limits the optical response. So there are many challenges. But graphene, and with suitable device structure, can overcome most of these challenges. And we can control light in a very broad spectrum, almost from visible all the way up to microwave. And today I will give you a couple of examples for that. So if we look at absorption of single-layer graphene, we know that graphene absorbs all over the electromagnetic spectrum because of this unique band structure. And in microwave and terahertz region, single-layer graphene can absorb up to 50%. And by changing the resistance of graphene, and graphene behaves like a tunable metal, and we can change absorption and reflectivity by just controlling the sheet resistance of graphene. But if we go into infrared and visible, single-layer graphene is not enough, so we have to stack the graphene layers, and we have